Hi everyone. In this second section of regressions, we will be examining multivariable or multivariate regression models. Here are some additional features that can be incorporated to regressions. Well, first of all, we can incorporate more than one variable as opposed to the simple model. The variables can be quantitative, linear, or nonlinear, and they can also be binary. Variables can be combinations of quantitative and binary variables, which we call interactions, and the impact a variable has on y can be examined independently of others. We may wish to use many variables to explain the variations of a dependent variable y. Assuming that we have populational data to work with, the best fit equation that describes a relationship between y and the different x's can have the following form, where y is expressed as beta 0 plus beta 1 x1 plus beta 2 x2, and so forth. As usual, you've noticed the use of Greek letters to represent populational values. The constant term beta 0 and the coefficients of the variables, beta k's, are parameters. Beta 1, beta 2, and so forth represent the rates of change, or the slopes, corresponding to a 1 unit increase in the corresponding variable x1, x2. Y is unaffected by variable xk if its coefficient is 0. On the other hand, if we have access only to sample data, then the best fit equation will require that we use Roman letters for the different components of this equation. The constants b0, b1, b2, and so forth are estimators of the parameters that we used to call beta 0, beta 1, beta 2 in a populational context. Variables x1, x2, xn are considered significant contributors only if we can prove that their coefficients are non-zero. This implies, as in the simple model, that we conduct hypothesis tests at some predetermined level alpha. Once again, you'll be provided with an Excel template. In the data worksheet, you will have to include, first of all, the values of your dependent variable y, in this case the weekly salary of a British teacher, and you will also incorporate the list of independent variables and their values in the columns x1, x2, and so forth. The use of ones and zeros under x1, x2, x4, x5 indicate that you wish to incorporate these variables, and zeros, for example, under x3 and x7, means that you are excluding these variables from your model. A multivariable regression is globally significant if at least one of the coefficients is proven different from 0. That means that our first assumption is to assume all of the coefficients for the x's are 0 until proven otherwise. H1, the alternative hypothesis, is to be proven, and this is to show that at least one of the coefficients is not 0. If sample data fails to reject H0, this would mean that none of the variables in the model has any effect on y whatsoever. The model, as it is useless. If evidence allows you to reject H0, then there is at least one variable that significantly affects y. This does not mean that all variables are useful, however. Again, in the template, under the data file or the data worksheet, the p-value for the global significance test will be provided at the top of the page. Variables themselves can be tested individually. A variable contributes to a multivariable regression if it is proven that its coefficient is non-zero. We will assume, as the null hypothesis, that the coefficient for a given variable is 0 until proven otherwise. So the burden of the proof is to demonstrate that there is a non-zero slope associated to variable xk. This test is repeated for all variables involved in the model. This time, in the template you'll be provided with, under the results worksheet, you can find the estimated value for all of the coefficients as well as the constant. B0, 1123, is the estimated value, or is the estimate, for beta 0, knowing fair well that this comprises some sample errors. Same goes for the estimated slopes, 31.5, which is acting on variable experience. The template also provides you with the p-value for each individual test. In this case, there are 9 variables and therefore 9 tests whose p-values are provided. Although the regression was deemed globally significant, you've noticed that not all variables have significant effects on the teacher's salaries. For example, experience did allow the rejection of H0 with a p-value that was extremely small. Therefore, we can accept that beta 1 is clearly not 0. However, variable sex had a p-value very close to 1, and therefore much greater than 1 or 5 or 10%, which are the typical values of alpha. We cannot reject H0, and hence we cannot conclude that a teacher's sex will have an effect on a teacher's salary. The estimated regression equation is provided in the results worksheet and allows you to find the estimated equation of best fit. So the coefficients that appeared in the column that we pointed out earlier are those that I've reproduced here in the equation of the estimated regression. In blue, I've highlighted the variables whose p-values were under 5%, and in red are the variables whose p-values were above 5% and therefore deemed non-significant. When interpreting the coefficients, you have to be wary of whether the variable is significant or not. For instance, we estimate that the average salary of teachers increase by $31 per week for every additional year of experience, assuming all other variables are the same. So for instance, 2 teachers that have 1 year difference of experience, one will earn $31.50 more than the other on a weekly basis. However, although the coefficient for x is estimated to be minus 1.03, it was not deemed to be a significant contributor, and therefore we cannot conclude that men and women who present otherwise identical characteristics have different average salaries. In other words, you cannot interpret minus 1.03 as meaning one of the 2 sexes has a lesser salary. There are variables that are non-quantitative that we'll also be able to interpret and use. Binary variables are variables to whom we attribute values of 0 or 1. The coefficient of a significantly binary variable expresses the change to the average value of y for those who have been attributed a value of 1 compared to those who receive a value of 0. 1 and 0 are basically success-failure situations. There are variables that we also consider as categorical, which are qualitative variables that have at least 3 possible outcomes. Now remember that regressions can only treat binary variables, and this means that a categorical variable will have to be recoded. In our example, teachers graduated from 5 different programs, which are not quantitative, these are categories. So the variables degree 1, degree 2, up to 5 are binary codes associated to these programs. Although degree 1 was absent from our model, it is understood that if 0 is attributed to degrees 2, 3, 4, and 5, then the teacher must have a degree of type 1. So by elimination, you don't need to include all n categories, but rather n minus 1. Degree 1 in this case, although it's absent, is used as a reference category. We estimate that teachers with a degree of type 3 earn, on average, $832 a week, more than those of degree 1, assuming all other characteristics are the same. And this is what we mean by degree 1 acts as a reference category. So 832 is a comparison to those with a degree 1. Since degree 2 in red is not a significant contributor, we cannot conclude that teachers with a degree of type 2 have average salaries that differ from those of type 1. And this, considering all other characteristics, are the same for these individuals.